All right, so this is the Secure Coding Pirate class. I appreciate you people being here for what's essentially a beta test, and we're talking about web security today, which is basically just a quick summary of some of the main topics of CNET 129S, our hacking web pages class. So, he covered a couple of the most common things. First, he talks about these frameworks, which, by the way, is really important, and I've been discussing this with one of the students that comes to my physical classes. It's getting very hard. You can't just right-click and view HTML anymore to see the source code of a page. Every page is built with these frameworks, and these frameworks mean that everything about the page is like 4 or 5 layers deep in JavaScript subroutines and stuff. It's like learning a whole new language to understand what's going on with web pages the way they're built these days. This is why people often criticize me, saying my website is incredibly out of date. It looks like it was built in 1995, because I did build it. I learned how to make websites in the 90s, and I wrote it that way back when life was simple, when you had HTML pages and CSS, stuff like that. You just put in a file, and everything was not created with JavaScript. But now everything is created with JavaScript and all the modern frameworks, so we'll mention those a little bit. And then the web security model and how it works. So there's the frameworks. Here's popular frameworks, and I know very little about these. I've written a Node.js app just once for a client that really wanted it, and I've included Express in some versions of it just to let people see what the consequences of using the wrong versions of Express are. And I've heard of Angular. The rest I've never used, but this is what you do. Apparently, if any of my students are actual web developers, they can enlighten me. Apparently, this is what you do these days. You learn how to use one of these frameworks and all of its features, and that's how you make a modern-looking website. And everything is just layer on layer of JavaScript. It's very hard to figure out how they work. Anyway, that's how it is. And therefore, if you're going to make a modern website, you would choose a good framework and then trust it. Make sure that you're using its security features. Now, one I know is WordPress. And WordPress has a whole lot of plugins. It has a few plugins that are very good, that do things like give you two-factor authentication and encrypt everything and such. And there are just many, many plugins written by amateurs that are sloppily made, not maintained, and open things like SQL injection and cross-site scripting. So there I understand this general philosophy absolutely works. I took a course in WordPress, and you have to choose a good framework and then carefully choose the good features to turn on, and not just frivolously turn on everything that looks good without knowing how much harm it's going to do to you. So here's some guidelines. Choose a framework produced by a trustworthy team. Look for security declarations, security documentation, and past performance, and test it to see if it works for your purpose. Sounds like a good plan. All right, so the web security model in general, in a browser, works like this. Your web server has some data, and it's going to take requests from the browser and hand it up to the client, and the web server can control how it handles the data at its end. But fundamentally, the web server cannot control with what your browser does with that data. And this is the fundamental reason why websites get hacked all the time. Almost all the vulnerabilities come from web designers not understanding the difference between server-side and client-side enforcement of security barriers. The server can control what happens at the server, but it cannot really control what happens at the browser. Now, normally, a normal user just opens a web browser like Chrome, and then they just click on the buttons and stuff that is in the web page that the developer put there. And therefore, most pages work fine under those conditions. The problem is you can do other things. You can turn off the scripting. You can use a proxy like a Burp that lets you modify requests so you can put in stuff that the designer never intended for you to change. And this is what leads to almost all the vulnerabilities. The web designer assumes that the client is just using a normal browser and behaving in an expected manner. And if the attacker is using a more powerful tool or technique, then they can send unexpected responses back, and the web developer did not consider what was being really, how much they were trusting the client. So that's the problem. All right, so the HTTP protocol, you send requests up. Everything depends on this uniform resource locator. You have a scheme first, HTTP or HTTPS, but there are others, but those are the main ones. Then you have a domain name. Then you have a path, which is a series of folders and a page name to specify which resource you're reaching, although with a lot of modern frameworks, that actually would be sort of a symbolic path leading to some script on the server that would find things not exactly literally in those folders. But on simple pages like mine, that's in fact folders and file names. Then you have a question mark, followed by parameters. This is often called the query string because in the simplest kind of search engine, this is where the search parameter would be. You have a name equals value, series of parameters, a question mark followed by a name equals value, and then if an optional ampersand and another name equals value. Those are the parameters. And then you have a pound sign and a fragment at the end. And the fragment is a way to move to a specific location on a particular page, a way to basically to scroll down partially. And those are the main features of a URL. And of course, you can't use a URL directly because you can only refer to websites by their actual name in the traffic, so DNS is the protocol used to resolve the domain name to an IP address so you can actually send the traffic. So an HTTP request looks like this. I just caught it and burped to see it. All you really need is the first two lines. Get the name of the page, name of the path, HTTP 1.1, and then the host here, and then a blank line to end it. The rest of this is all optional headers that can specify more, like what your browser is and things like that. The verb right here is the first word, also called the method. There are a bunch of them, but the most common ones are get and post. Then you get a response, which gives you a status code, and again, all the rest of it is optional. The status code tells you what happens. 200 means it found what you were looking for. 404 means it couldn't find what you were looking for. 302 is a redirect. 500 is a server error. And these things here tell the browser what it's supposed to do with the data that's coming. You asked for something, I found it, and I'm giving it to you. Here's all kinds of information about it, and here's the actual data down here, the website coming in. So you have these things like X-frame options and so on. These tell the browser whether it should allow this page to load in an iframe, and there are other ones that have to do with cross-site scripting and many other vulnerabilities. So these all are very nice things to add to your server response to protect the user from various flaws. The problem is you cannot trust that any of this will actually take effect because you don't know what browser they're using. These are requests for the browser to please obey my policies, but you have no control over whether the browser actually does that. So get request content and typically does not change the state on the server. You shouldn't send sensitive data in the gets, and this is fundamentally what Kaiser did, right? They have somebody doing a search on their web page, and they're sending up a search for like cancer. Here is the query, and that information is being sent off to advertisers and trackers. And that's what they really shouldn't be doing. So if you were to log in with a name and password up here in these parameters, you can do it technically, but it is not recommended because all the data here is typically put in server logs and favorites and so on. Data in the URL itself is not considered confidential and treated that way, whereas data down in the post is not included in the URL. So it's considered better to put sensitive data in the post, not in the get. All right, there's also something called referrer policy. Referrers are sent along with a page. If you go to a page, I just clicked on some City College pages, and see it sends a referrer. This is the page it came from. Now, this has been there for a long time, and it was intended to be like the tracking and phone numbers. You know, when you make a phone call, the number, the identity of the person calling in comes in, caller ID. In both cases, and it's like the from address in an email message, it is a convenience, but you can't trust it. You have no way to verify this referrer is accurate, but the idea is you would then know whether someone came from your page or they came from a search engine or something like that, which might be interesting for you to know whether your advertising paying to a search engine is bringing in people or not. And by the way, it's spelled wrong here, and that is the official HTTP specification, so you have to spell it wrong. Anyway, this could in principle leak out information. If there was sensitive data in the URL, which there shouldn't be, then it could be in the referrer, and that would pass it on to the next page you go to. So you might not want this referrer header to be sent along with the page. There is a referrer policy you can put on your page saying, here's the page, but when you click and go somewhere else, do not tell the next page where you came from. But again, that's a request for the browser to do that, and you have no way to know if the browser actually honors that request. All right, and then of course encryption and authentication of servers. HTTPS provides an authentication that you know what server you're talking to, and an encryption key so nobody else can see or modify the data you're sending to that server. So this assures the server is genuine and prevents eavesdropping and adversary-in-the-middle attacks. It does not stop attacks like cross-site scripting and SQL injection, because those rely on transmitting data to the server, which is misunderstood at the other end. All it does is provide a protected channel so people between you and the server cannot inspect and modify your traffic, which is extremely important. It is considered unadvisable these days to have any HTTP content on your page at all, because anybody could modify that in transit and they could add scripting to the page over HTTP. So every modern page should be loading over HTTPS only. So the certificate is here. It identifies the person you're talking to, the server you're talking to, and ultimately the most important information is it gives you a cryptographic key, which you can use to encrypt the data. So now you know you're talking to the right server, and you have a key you can use to encrypt the data so you know that nobody else can read or modify it, and that's how it works. And it works very well. Breaking into HTTPS is not impossible, but it's really quite rare. All right, reverse DNS is another option. You might take the IP address and reverse it to figure out where people are going, but this is of limited value because many IP addresses host many websites, and there are reverse proxies like Cloudflare in use and so on that disconnect an IP address from the domain name. Let's Encrypt greatly improved the use of HTTPS by providing free HTTPS certificates for everybody. Now, there have been various types of certificates. This just validates your domain. There have been other ones where they'd actually make some attempt to make sure you're a legitimate business from a somewhat trustworthy country and so on. But these are pretty much going away because the free certificates are good enough, and free drives out the expensive stuff. There have been downgrade attacks, where you downgrade from HTTPS down to HTTP or to a lower TLS version with a shorter cryptographic key, especially since in the 90s the U.S. government made the extremely unwise decision of enforcing weak encryption on the internet for so-called security. So there are these deliberately insecure cryptographic protocols in use on the internet. And so what's best practice to prevent that is to configure your server to only accept secure modern methods, and you accept that if there are people out there trying to use really old browsers like Internet Explorer 3 on Windows 95, they're not going to be able to see your page. You're not willing to downgrade to that level. You can also include strict transport security in your HTTPS response that tells the browser to only load content over HTTPS, which is the way everything should be. You can also put the secure flag on cookies, saying only transmit the cookie over HTTPS. Again, I mentioned you have no way to know if those requests are actually honored by the browser, but usually they are. All right, and I'm going to talk about the same origin policy, but before I do that, I'm going to step out a few minutes. I'll pick up at 9:35. Be gone for 10 minutes.